Hi, good day everyone. Today we are going to be doing a summary of number 3 paper 2 CSEC math questions. Right? Excuse me. Okay. First thing we're going to be talking about is the topics. This section being tested. So the section being tested is section, let me make sure and tell you the correct thing. The section being tested is section 8, which is geometry and trigonometry. Okay? Um, so the section being tested again is section 8, geometry and trigonometry. Basic stuff in comparison to number 9, which is the more in-depth geometry and trigonometry, right? And in geometry and trigonometry, the first thing we need to do is bisecting angles, right? Producing angles such as producing angles with ruler, compass, right? With ruler and compass only, right? And well, you could use your protractor to just check. Then we have types of angles. Before I move on, when we have producing angles with ruler and compass only, we're talking about 45. Let's start with the smallest: 30, 45, 60, 90, and well, not 270. We'll just leave it at that. Alright, types of angles. Then the next thing we're going to be looking at is SOHCAHTOA, which is your right angle triangle. The Pythagoras theorem, right? As at a right angle. Then the next thing we're going to be doing is transformations, which include which includes translation, rotation, reflection, as well as enlargement. And I think there's a few other things. Oh, interior and exterior. When I say types of angles, We could take off right angle triangle. Types of angles. We also have to learn interior and exterior angles. Right? These are the things that are being tested on for number 3. There may be a few others, but these are what I have done from the top of my head. Now, the first thing we'll be doing is bisecting an angle. And please learn how to do this. Reason is, especially when we're doing transformation of rotation, you need to know how to bisect a line. Right? So, if we have to bisect a line, let's say this is the line that you have to bisect, right? Or find the perpendicular bisector. What does perpendicular bisector mean? It means to bisect this line, half of it you're bisecting at 90 degrees. When you have your protractor, this is your compass, sorry, you're going to take your compass, put it at one side of the circle, like so. All you need to know is when you're opening up that compass, it has to be more than half the line, right? You're going to draw an arc. You don't need to draw it as big as me. Hold on. We'll need to move this line. Right, so you draw an arc. Draw next arc. Then you take this line and do the same thing. Right? Let's just shift it. And the major thing we want is those two arcs that we drew on top and below to intersect. So you see what those two intersections are at? You're going to take a line and intersect. Now, this is how you find your perpendicular bisector of a line. Right? If we were to take our ruler and measure this from 0 to, let's zoom it in. This is a little bit 9.5. It is actually half of that, right? Half of 9.12, 9.7. So 9.7 divided by 2 is 4.85, and that is exactly where this intersected. 4.85. You can check it to make sure. But this is how we find the perpendicular bisector, or how we bisect a line. Okay, now, not an angle, I should say bisect a line. This would be needed a few times to do a few things. This is bisecting a line. How would you bisect an angle now? Angle. Let's just say I'm going to draw a 60 degrees angle with my protractor. Right, so you're going to draw a straight line like this. Hold on, no, not like this. Let's make this protractor a little bit bigger so we can see it properly. Right, I'm going to draw a 60 degrees angle. With the protractor, with the help of the protractor, that's the center there, you draw a line. And then your 60 degrees will be right there. You're going to connect this line and this here, and that is 60 degrees right there. Right? Now, if they give you an angle, and let's just say you have to bisect that angle, the first thing you're going to do is take your compass and you're going to draw an arc. Right? Right. And you need to make sure and intersect the lines of that angle. Right? Then you're gonna take where it intersect that first line, you're gonna take the pointy part of your protractor and put it there. You're going to draw an arc on top. Right? Draw an arc. And you're going to do the same thing with the next part where that arc intersected that first line, that second line in your 60 degrees. Now, where these two arcs intersect would be the bisector of this angle. When I find the bisector of this angle, it means that this angle here should be 30 degrees. If I take my protractor and measure it, I'll make it a little bit bigger so you guys could see. You can immediately see that this is 30 degrees. So to bisect an angle that you are given, you draw an arc, and where that arc intersected the lines of the angle, you will put it at the point where the line intersected the arc and the arc and the line for the angle intersect. You're going to put the pointy part and draw an arc, and then you're going to do it with the same. You're going to repeat that step for this side as well. And where those two arcs that you created intersect would be half of the angle, right? And this is how you would bisect an angle and a line. Right? So we have learned how to bisect, right? Producing angles with your compass and ruler only. Very easy to create a 60 degrees. Right? Let's create a 60. Now, if you understand how to bisect angles, making these lines are going to be very easy because half of 60 is 30. So if you bisect that 60 degrees that you have created, you'll get 30. Same thing with 90. If you know how to create a 90 and you bisect the 90, you're going to get 45. So as usually, learn how to bisect and then learn how to create a 60 degrees as well as a 90. Those are the two most important ones to create. Right, so first off, let's put this a little bit at the sides here. You take your compass. Note that if you're opening up this line, make sure it is more than at least half of the line. Right? Also, you have to make sure that this space that you open up your compass is not changed. It cannot be changed, okay? It has to be the same throughout. So the first thing you're going to do is draw an arc. Right? Let's draw the arc here. Then where it intersected that line that you drew, you draw a next arc. Right, now you connect your starting point, which is this point here, and that point where it intersected, and that is 60 degrees. It's always 60 degrees. If you take your protractor, let's open it up a little bigger so we can see. That is how you produce a 60 degrees angle. Now that we have created a 60 degrees angle with just our ruler and our compass, let's create a 30 degrees. So where does these two intersect? There are two lines. There's this line here and this line here. So you're going to keep it. Do not change the distance, please. And you're going to create a next arc. So you're creating an arc here. And then you're going to do the same thing where the 60 degrees line is at. That's this here. And you're going to create a next arc. Where these two lines intersect would be how you create a 60 degrees. Right? If you take your protractor and check it out, zoom in, that is how you would create a 30 degrees. Right? That is how you produce a 90 and a 30 degrees. Now, if you create a 90 or if you create a 30 or a 60 and you subtract that from, let's say, 360, if they ask you to make a 300, you create a 60 degrees, and then the remaining, which is from here, go right around back to here, would be 300. Right? If you create a 30, and let's say you want to create a 330, from here, go right back around to here, where the lines where 30 degrees is at, would be a 330. So from these two angles, from creating 60, you know how to create a 300, and from creating a 30, you can make a 330 as well as a 30 degrees, right? So this is to produce a 30, a 60, and a 30 degrees angle, right? The next thing you're going to learn to do is create a 90 degrees. Now, first things first, make a 90 degrees. Right, make a line. Then you take your compass. Most important part about this compass is that the compass must be more than half the line. You draw ooh, this is so big. Let's make this a little bit smaller. Right? We're gonna create a line. Right, now we're gonna take our compass. This compass, if you look at it, it's pretty long, right? So we're gonna make it a little bit shorter. Again, you just need to make sure that this is more than half the line. It is. Let's create it a little bit smaller. Right. So you're going to first create an arc. Right? Then you're going to create a next arc. Right? Again, don't change the distance, right? So you make your 60. The 60. Right? And then from here to here, you create a next line, a next arc, intersecting that first arc that you made. That's this line here. Now, if I were to measure from here to here, that would be 120 degrees, okay? So this is 120 degrees. So now you have learned how to create 120 degrees. But this is not what we're doing. We're doing a 90 degrees. So after you have made your 60 degree mark, after you have created your 60 degrees mark and your 120 degrees mark, you're going to create an arc on top here where those two intersect. So I'm going to take my protractor, compass, sorry, and I'm going to create an arc on top here. One, let's go up, and then the next one from here. Again, never change the distance, right? Two. Shoot. 2. After you have created that, you're going to join the initial point, which is here, with that intersection, and then that is how you would create a 90 degrees. Check, you use your protractor. If you put your protractor here, let's make it a little bit bigger so you guys could see. It is in fact a 90 degrees. And this line is in fact 120 degrees. So you have your 90 degrees, you have your 120. Now, if you intersect or bisect a 90 degrees, the opposite of, not the opposite, 90 divided by 2 is 45. So if I were to bisect this 90, I will get 45. So to bisect, you take your that arc that you have created, and where it intersects those two lines for your 90, you create a next arc. So you're going to create a next one, which is right here. And then do the same thing for the next part of that 90, which is right here. Now, where these two intersected would be your 45 degrees. So if I create here to here, that is actually 45. If you take your protractor again, we'll open it up bigger so we can see. You can in fact see there is a 45. Well, let's just center this a little bit better. Right. There's in fact a 45. This is 45 degrees. This is 90 degrees, and this is 120. If you had to create a 60, If we join this line and this arc here, that would have been a 60 degrees. And that is how you would create a 120, a 90, and a 45 degrees angle with just your compass and ruler. And that is how you would produce a 120, 90, 60, and 45 degree angle with ruler, pencil, and compass only. Which is very important because they do want to see those lines. When they tell you to create an angle with using a ruler, pencil, and compass only, they are looking for, you see these lines are these arcs that I have created, that is what they're looking for. So if you think you're just going to use your protractor, you need to you can use a protractor to check it over. However, you do need to have these arc lines down to make sure that the examiner will know that you have been using your compass and pencil and ruler only to create what was asked. Right? So that is how you would do that is how you're going to create your 30, 45, 60, 90, and then I have also created a 120, right? Types of angles. Right? Now, for types of angles, what we have to know, if there's two parallel lines and then a transversal line cuts it, there is corresponding lines are equal. So this line will correspond with this angle corresponds with this angle, this one corresponds here, and this one corresponds here. Those are equal. Alternate angles are equal. If you see two parallel lines and a transverse line and it forms a Z, right? The internals of your Z are equal. Vertically opposite, if you have an X, the opposite angle, so this angle here and this angle here would be equal because they are vertically opposite each other, right? Interior angles on the same side, so if we have two parallel lines with a transversal side, we have two interior angles on the same side, they are supplementary, meaning they're 180 degrees, right? And also we have things like a straight line is 180 degrees, a whole revolution is 360, those type of things, which is, knowledge base, right? That you should know. The next thing that we have to do is Pythagoras theorem and SOHCAHTOA. Pythagoras theorem, what do we know about Pythagoras theorem? If, first of all, Pythagoras theorem and SOHCAHTOA have to do with a right angle triangle. If you have a right angle triangle here, you need to learn how to identify, first off, Pythagoras theorem. The side that is opposite your 90 is your hypotenuse, which is also the longest side in the triangle. Your hypotenuse squared is equal. Let's say call this 1 and side 2 would be equals to 1 squared plus side 1 squared plus side 2 squared. If you want to find your hypotenuse, it will be the square root of 1 squared plus 2 squared. That is how you find your hypotenuse squared. If they give you a hypotenuse on one side, you just need to learn to rearrange your formula. And you want to find out side 2, you carry this across, that would be hypotenuse squared minus 1 squared is equals to 2 squared. And you want to find side 2, so 2 or side 2, let's put side 2 would be the square root of your hypotenuse squared, put open bracket, hypotenuse squared minus 1 squared close bracket. So you find the square root of the subtraction of these two numbers. Right, and that is how you would find, that is Pythagoras theorem in a nutshell. The next thing is for SOHCAHTOA, I would say that you need to learn to identify sine, opposite and adjacent. Hypotenuse does not change, it is always the side opposite your 90 degrees. This is your 90, this would be a hypotenuse. Right? However, what you do need to learn is how you would how would you recognize an adjacent and an opposite? Opposite side is the side that is opposite the angle that is not 90 degrees. So if they gave me this angle, this side will be my opposite, right? So my opposite is the side opposite the angle that is not 90 degrees. So if you have a next angle that you're looking at, that is the angle we're going to be talking about, right? And then my adjacent side would be the side that has the 90 degrees and the theta, or the angle that is given. Now, depending what is given, that is when we use so, ka, toa, which means sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, and then tan theta is opposite over adjacent. So depending on what the question gives you, that is when you know whether to use sine, cosine, or tan. And that is um, hypotenuse, Pythagoras theorem, as well as SOHCAHTOA in a nutshell. The next thing that we have to learn is interior and exterior angles. For interior angles, let's talk about the sum of interior angles is this formula. Please don't forget it. 180 open bracket n minus 2 close bracket. The sum of interior angles, where n is equal to a number of sides slash angles. The number of sides and the number of angles correspond with each other. So if you have a three-sided shape, it would be 3 angles. If it is a four-sided shape, 4 angles. If it is a five-sided shape, 5 angles. Just depends, right? Then the sum of exterior angles is equal to 360. No matter how many sides it is, it's always equal to 360. Right? And that is basically what you want to know for some of, oh, also, if they say regular polygon, a regular polygon is a polygon where all sides and all angles are equal. Okay, so when they say regular polygon, it just means a polygon where all sides are equal, hence all angles are equal. So what we know is your side corresponds with your angle. The larger your side, the larger the angle. So if all sides are equal, then all angles are also equal. Now the last thing that we need to learn for number 3 is the transformation. Now, in CSEC, they are only going in the transformations. In CSEC, they are only testing 4 types of transformation. 1, reflection, and they'll ask to describe it. So to describe a reflection, you need to know location of your mirror line. Right, number 2, you're going to do rotation. Rotation, you need to know center of rotation. You need to know center of rotation. You need to know, this is a coordinate, by the way. That is the point at which it rotates. You need to know direction. That is if anti-clockwise slash clockwise. The only time this wouldn't matter is if it is 180 degrees. Doesn't matter. It would be clockwise, anti-clockwise, it would be the same. So center of rotation, oh, and the degree of rotation. To find the degree of rotation, that is your the angle, how big the angle is, and you use your protractor to solve this, right? That's number 2. Number 3 is reflection, rotation. It have enlargement. Oh, translation. Now translation can be described using a, what you call it, a column vector, where the value on top is your displacement along the x-axis, and y is your displacement along the y-axis. And number 4 is reflection, rotation, translation, enlargement. Enlargement, what is enlargement? You need to find K, that is the center of enlargement, center of enlargement. I think I ran out of space, guys. 1 second. Right, center of enlargement, your scale factor, and your scale factor. Factor, which is also known as K, which is your image, the length of your image over the length of your object. The number of times your image is bigger than your object would be your K value. And that is the things that you need to know how to describe it, which is one of the things that we'll be doing, right? And when we're doing the past papers, I'll really go through how about rotation and, yeah, rotation, which is one of the harder ones in comparison to the others. So yeah, let's go ahead and start the past papers now. First question says, the diagram shows a regular hexagon. What did I say about regular? When they say regular, it means all sides are equal, right? A regular hexagon, LMNOPQ. When I say regular hexagon, all sides are equal and all angles are equal, right? So if this is 8 centimeters, one side is 8 centimeters. So this is 8, 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 this is 8. Show that the angle, the value of an angle PQR, which means one angle is 120. Now we know that the sum of interior angles would be 180 times n, which would be 1, 2, 3, 4, 5, 6, 6 minus 2, which is 180 times multiplied by 4, which is 540. 5, yeah, 8 fours, 8, 8, 8, no, that's not 540. 180 times 4 is 720. That's what I want to know. Is 720 degrees. Right? 720 degrees. So if that's for the sum of all and you want to find the sum of one, so one angle would be 720 divided by 6, which is equal to 120 degrees. And that is how you could show that this angle is 120 degrees. Right, this question tells you, let's just shift and the vertices of a triangle WXYZ touch the sides. PQ, QL, MN, and NO of the hexagon. Part E. In Part A, ZY and X and WX are parallel to LM and PO. So all these are parallel. Calculate the value of LWX. LWX. So 1 off, we know that this is 120 degrees. Why? Because all sides are equal. Yes? We also see, if you're not seeing it yet, two parallel lines, and there's a transversal line. So WM and WX are your two parallel lines, and LW is your transversal line. What do we know? If we go back, where is it? Interior angles on the same side of the transversal lines are supplementary. So we know that 120 and the angle that they're asking you, LWX, are supplementary to each other. So LWX plus 120 would give you 180. So LWX would be 180 minus 120, which is equals to 60. So this angle here is 60 degrees, and that is how we would do this question. Do we understand this, everyone? Next one, the field of a sports club is in the shape of a quadrilateral, just means a four-sided shape, RSTU. A scale diagram of this field is shown below. Alright? The lamppost is erected in a field at the point marked L so that the floodlights can be installed. The point L is located in such a way that L is perpendicular bisector of UR. So you need to find your perpendicular bisector of UR, and then you need to create a angle LST so that angle S is 30 degrees using compass and ruler only. Locate where L, so the line at where 30 degrees and your perpendicular bisector intersects would be where angle L is located. So first off, take my compass. I'm going to make it a little small because again I just need it to be more than half my line. First off, I'm going to do the harder part, which is to make my 30 degrees. Right? So the first thing you're going to do, I'm just going to make a smaller, right. So I am going to make a arc first. Create an arc, right? Then where it intersected the line, you would make a next arc. So we know that this line from here to S is 60 degrees, and then we need to find out where the perpendicular bisector is. So we're going to, hear me, perpendicular bisector, we need to find out where your 30 degrees is. So you are going to now make an arc here, and then let's make this a little bit bigger. I'll erase afterwards. Right here, make an next arc. So we know that this is where our 30 degrees angle is at, and if you're not 100% sure, you can use your compass to find out, to make sure that, not your compass, you could use your protractor to find out this is 30, which we can see is 30 degrees. So we have made L is located along this line here, ST. So far so good? Then we need to find the perpendicular bisector of UR, which is going to be easy. I don't need to make this so long. I'm going to make the so short, sorry. I'm going to extend this line. Oh. Right? And I'm going to create, hold on, undo that. Create a bisector on top here. A bisector there. Then create a next bisector here. Oh shucks, I'm supposed to create a one at the below. And also, I don't like it. Let's use a different color so we can distinguish it, right? So you're going to create a bisector on top. right? And then you're gonna create not a bisector, arc. Oh, a arc below. Right, let's just make it below. Right. Then this one you're gonna make the same thing, an arc on top and below. So honestly, I don't even need all of this. I could probably erase it. Because all is not necessary. What is necessary is where they intersect, right? And then I'm going to create an arc below. That is right here. Ooh, right here. So again, what is not necessary? All these lines here, right? All these lines here. Right. Now, where those two lines intersect would be your 90 degrees. I'm going to connect those two lines. Right. And if you want, you can take your protractor, check to see if it is 90. We need to line up this line here. You are. And you can in fact see, or if you can't see it, let's just make it a little bit smaller. You can in fact see that that is 90 degrees, right? So let's move this protractor. Where the line, the black line, which is my 30 degrees, and my perpendicular bisector intersects is going to be L. So L is going to be right there. L is going to be this line right here. Right? And that is how you would locate where L is located. And that is January 2025, an easy 9 marks. So let us go on to the next question here. This is May, June 2024. A vertical flagpole FP stands on a horizontal ground and it is held by two ropes, PG and PR, as shown in the diagram. What kind of triangles are we seeing here? We're seeing one 90 degrees and next 90 degrees. So create this, say that this is 90 degrees as well. Okay. They say that PG is 18, FR is 9.7, FGP is 28. Calculate the height of the flagpole. Now, in this one, we only get one thing, so you're not going to use triangle PFR. You'll be using triangle PFG. So, they told us calculate the height of the flagpole FP. Now, I'm going to be looking at this triangle, which is a 90 degrees angle. This is my hypotenuse. So my hypotenuse is equals to 18. Theta is equals to 38. And then they want to find FP, 38. FP is equal to the opposite. Right? That's what they're trying to find out. So now, ka toa. There's no adjacent, so it can't be this one and can't be this one. So it will be sine 38 is equals to FP over 18, divide by 18 over, so that's 18 sine 38 is equals to FP. The only thing is, make sure that your calculator is in degrees. 18 sine 38, which is 11, 18 sine, yeah, 11.08190656. If I'm standard for CSEC is to 1 decimal place, so it'll be 11.1. Draw a line here. 8 is more than 5, so I had to add 1 to that 0. So it'll be, and this is meters to 1 decimal place, and that is your answer for this question. Did you get this, Jashon? Good. Part 2 now. I know this is 11.1. And I want to find my hypotenuse. So hypotenuse squared is equals to 11.1 squared plus 9.7 squared. So my hypotenuse would be my square root of open bracket 11.1 squared plus 9.7 squared. Exactly how I wrote this down is what you're going to put in the calculator. Square root of open bracket 11.1 squared plus 9.7 squared close bracket, which is equals to 14.74109901, which is approximately 14.7 meters to 1 decimal place. Again, CSEC has a standard of 1 decimal place unless stated otherwise. Alright, let's look at the next question. Next question here, this is types of angles. So let's see what they said. We have 2 parallel lines and a transversal line. Before I even read the question, this is what I have viewed so far. In the diagram below, QP is parallel to MN. LRT is an isosceles, meaning this side here and this side here are equal to each other. Right? LRT is 28. Did they tell you that? Yes, they said. And STL is a straight line. Right? Okay, find the value of x. So first off, I know that there is a alternate angle. If we go back, if you see a z, hold on. If you go back, remember, if we see a z, those are alternate angles which are equal. So immediately I know, let's zoom in, that this angle here is 28. Let's put it in red. This angle here is 28 degrees, right? We also know that this is an isosceles triangle. We know properties of an isosceles triangle, bases are equal. So if I have this angle here and this angle here would be equal. Let's call this E. So I know that from this it's 2A plus 28 is equals to 180. So 2A is equals to 180 minus 28. So 180 minus 28 is 152 divided by 2. So A would be 152 divided by 2, which is equals to 76. Yeah? So this angle here is 76 degrees. This is 76. Now, if you look at X and this blue and red angle, you can see that these two angles are vertically opposite. And we know, according to our rules, vertically opposite angles are equal. So, I would say that X is vertically opposite 76 plus 28. 76 plus 28, which is 104. And we know vertically opposite angles are equal, so x is equals to 104 degrees. And that is how you would find this angle here. Part C is our transformation type question. So let's see. The diagram below shows a shape T and its image Q after a transformation. What type of transformation is that? That cannot be a rotation, it cannot be an enlargement, it cannot be a it cannot be a translation. Translations, the orientation does not change. These two change. It cannot be enlargement because one is not bigger than the other, or it can't be a dilation and one is not smaller than the other. It cannot be a rotation because if you were to rotate it, any first off, they said it is mapped on from shape T to shape Q. If you rotate any way for T, there's no way that you'll get Q. So it can't be that. So the only thing that this, through a process of elimination, we would say that shape T is reflected on the mirror line y is equals to x to produce image Q. Right? How do I know that? Because the reflection is going here. And this line here is where y is equals to x. Also, if you take from one side to the other, you can see that the distance from the object to the image is 1 unit. So your mirror line is going to be 1 divided by 2, which is a half. So it's going to be a half unit away from the object. Your mirror line is going to be a half unit away from your object, or a half unit away from your image. Just depends on what they're asking. Right? Let's look on this. On the diagram above, draw the image of t after it undergoes a translation by vector minus 1, 6. Remember, if they give you the translation like this, the one on top is your displacement along your x-axis. One at the bottom is displacement along your y-axis. Right? Displacement along your x-axis, if it is -1, that means it's going to the left-hand side. And then 6 units, y is positive, so it's 6 going in the positive direction. So let's take 1 point, we're going back and then counting 1. 6. 1, 2, 3, 4, 5, 6. Alright. Do the same one. 1, 1, 2, 3, 4, 5, 6. So it's here. And then you can just create your image. You know, it's 2 units down. Then how many? 1, 2, 3. 1, 2, 3. Yeah. Right. So now we know that this is how our image is going to look. Or the next way you could have done this is you could have, I'll call this image M. Right. As I was saying, the next way that you could have done this is you could have taken a coordinate, right, and then add it to the transformation, and that would give you your object. Sorry, you could have taken your object, take a coordinate of your object, add it to the transformation that we have here, and that would give you an image. So let's just say this is 4, 3. Well, this is 4, 3. Let's check and see. 4 on top, 3 at the bottom, plus -1, 6 would have given you not negative 3, 3, and 6 plus 3 is 9. So the coordinates for 4, 3, this is your object, this is your transformation, and this is your image. Your image for coordinate 4, 3 would have been 3, 9. And if you look up here, this is 4, 3. This is what? 3, 9. So you see that this is actually your transformation. So this is correct. So if you want to do that for all coordinates, or if you want to just shift your coordinates, you can, if you want to take the coordinate and move it, you can do that as well. Whichever one you're comfortable with. This is 1 mark, so you don't need to do that much working for it. This here is January 2024, so you see they're bringing back these these producing angles and stuff, right? Using a ruler and compass only, construct ABC. Line AB has been drawn for you. They told you AC is 8 and BC is 5. They didn't tell you any angle, so all you need to know is there is a spot where when AC is 8 and when line BC is 5, where those two lines intersect, this is where your C is going to be located, right? So the first things first, we're going to take our ruler, take it out. You're going to take your compass and you're going to open it 8 centimeters long. So from 0, you can open it out to 8. Right here is 8. Right, let's change this to black. Then, ooh, hold on. I hope this is, so I know that this angle is going to be some, oh, I think. I'm just gonna show you where it's supposed to be, right? Because most likely, um, my one, if you open at 8, it'll be okay for you, right? I am just gonna open it because I don't know, because 8 is a lot. I'll just open it 4. So I'm just halving everything, right? Just so that we can find a location. Because I think hold on, I think I need to, right. 1 second. Let's open this 8. Yeah, I think the this is right. So somewhere here. So you're going to start from A. C is going to be somewhere around here. So you're supposed to open it up 8, right? So I'm just doing this just for an example here. And then C is going to be somewhere located along this line. And then they said BC is 5. So I am going to I'm halving everything, so I'm going to say half of 5 is 2.5. Hopefully I can open it up 2.5. Right? Let's just say we're doing this here. B is here, and you would have, let's just say this is 5. You're going to do the same thing. And where A, the arc for C, AC, and the arc for AB intersect, that is the location for C. So C would be somewhere around here. Right? And that is how you would have drawn triangle ACB. So C is located somewhere here. So C is here. Right? Measure and state the value of angle BAC. BAC. BA. So angle A. Hopefully this is correct. This would be, hold on. To here I'm getting 40, which could be, you know, how I drew it, but yeah. For now, this would be angle 40 degrees, right? And that is how you would find this answer. Well, approximately 40. Do you understand? I think it's the magnification of the image, the magnification of this page. That is why I can't do 8 centimeters. Right? Do we understand this, Jashon? Okay. So now let's do an next one. This here we immediately see an isosceles triangle, and we also see a right angle triangle. So in the diagram below shows an equilateral triangle. No, not an isosceles, equilateral, meaning all sides are equal. FGH, whose base is 13. So this is 13 here, and that is also 13. They want to know the height. We know that the length from here to here would be half of this. So that's 13 divided by 2, which is 6.5. So h would be a side. So we know it would be 13 squared, which is the hypotenuse squared, is 8 squared plus 6.5 squared. You want to find h, carry this across. So I have 8 squared is equals to 13 squared minus 6.5 squared. So h is going to be the square root of open bracket 13 squared minus 6.5 squared close bracket. The square root of open bracket 13 squared minus 6.5 squared close bracket is 11.25. 11.25833025. So my height is going to be 11.3 the centimeters, yes, centimeters to 1 decimal place. And that is how you would calculate this. Right, let's go on to the next question. Again, they're bringing the transformation questions. Let's look at it. The diagram below shows 3 triangles, P, Q, and R. Triangle Q and R are images of P, so P is your object after it undergoes a double transformation. So P goes to R and then R goes to Q, something along those lines. Describe fully the single transformation that maps P onto R. They have the same orientation, so it's not a rotation. It's not an enlargement, so it's either a mirror line. It's not, because this is not inverted. So the only one it would be is it is a translation or a slide. So you can say that object P translated to produce image R. And how would you do that? How would you find it? You're going to look at how much you're going to take a coordinate and see how much it move along the x-axis and how much it rotated, not rotated, much it move along the y-axis. So you're going to go 1, 2, that's positive 2, and then we're going up 1, 2, 3, 4. So it is 2 units along the x-axis. So you can just say 2 on top, 4 at the bottom. Right? Or what you could have done is take a coordinate of P. Let's take this one, which is 1 on top, 0 at the bottom. Right? And then we go into 3 on top, 4 at the bottom. So 3, 4 minus 1, 0 would be 3 minus 1. So it is your image minus your object to give you a transformation, right? 3 minus 1 is 2, 4 minus 0 is 4, so you know that the transformation is it displays 2 units. So, or you could say object P translated to produce, so displays 2 units along the x-axis and 4 units along the y-axis. If you just put 2, 4, that would be correct as well, because this tells you that it displays, on top is the displacement along your x-axis, the bottom is the displacement along your y-axis, right? Then triangle R onto Q, we can see that the shape has been inverted, so immediately it's a mirror line. Now, it's a reflection. So object, I don't want to use object R because R is not an object. We'll say triangle R was reflected on the line. I'll leave a space to put it, to produce I don't want to say that. Triangle Q. So first off, you need to find your mirror line, the location of your mirror line. To locate or find the location of your mirror line, you count from the object to the image. You count how many units. Now you have to put corresponding points. You can't use this point here and then go to this point here. It has to be corresponding points. 1, 2, 3, 4. After you find the distance from your corresponding object to your corresponding image, you divide that by 2. 4 divided by 2 is 2. So you know that the distance from your object to your image, or from your, the distance from your object to your mirror line is 2 units, and same for vice versa. From your mirror line to your image, your object, it's your image, is 2 units. Right? So now we know that our mirror line is 1, 2, so it's somewhere here, which is not y, x is equal to 1. So triangle R was reflected on the line x is equal to 1 to produce triangle Q. Do you understand this? And that is our next 9 marks. May, June 2023, the diagram below shows a semicircle with a diameter AC. So, immediately when you read that, your circle theorem supposed to come back. If your diameter is part of a triangle within a circle, the angle opposite that diameter is 90 degrees. So this here is 90 degrees. Alright. Point B, and then they say this is a what you call this thing? This is a isosceles triangle. So these two angles would be equal. So let's call this A and let's call this angle C. So A plus C is plus 90 is equals to 45. 180, sorry, I'm saying the answer, 180. So A plus C would be 180 minus 90. A plus C would be equals to 90. Because A is equals to C, you can just say that that's 90 divided by 2, which is 45. So this is 45 here degrees, and this is 45 degrees here. Right? You're going to take this and you're going to go straight down. Right. We know if it intersects there, this is 90 degrees and this is 90 degrees. They said the circumference AB, this is 8.2 centimeters. Right? So I just did everything that just from reading that is what I brought up. State the geometrical name of AB. Because it is from one side of the circle to the other, not going through the center, immediately your mind's supposed to go on, this is a chord. Find the value of the radius. So we know the radius is from here to here. We know this is 45, we know this is 8.2. So let's write down what we have. We have C is equals to 45. We have the hypotenuse is equals to 8.2 centimeters. Then we have the center to C is that's what we're trying to find. We're trying to find the radius, not the diameter. Right? There is another way to do this question, but hold on. Right. So you can say that the radius, oh, yeah, if you have 90 and theta, remember I told you that your adjacent side has your 90 degrees and your theta, which is exactly what it has here. So your radius is equal to your adjacent side. We have hypotenuse and radius, so you put so it's not so. Ca, it is ca because it's adjacent and hypotenuse. So cos 45 is equals to your adjacent, which is a radius, over your hypotenuse, which is 8.2. So we know that radius, if I carry across 8.2, divide by 8.2, tends to multiply. So 8.2 multiplied by cos 45. 8.2 cos 45 is 5.79827560506. Sorry. So my radius is equals to 5.798275606. So my radius would be 5.8 centimeters to 1 decimal place. And that is the answer for this question. Do we understand this? And this is 3 marks. The next way you could have done this is you could have, could you? No, you could not have done that. You can't use cosine rule. But yeah, that's how you would have done this question. Right? This one, they said, each interior for a regular polygon is 160. We know that a regular polygon means all sides are equal. They're telling you that one length is 160. Calculate the number of sides of a polygon. So we know that your sum of interior angles is equals to 180 by n minus 2. That's what we know, right? We also know that one angle would be 180 by n, hold on, one angle would be 180 by n minus 2, whatever the sum of interior angles is, divided by number signs, which is n, which would give you 160. Carry this across, it would be 180n minus 180 by 2 is 360 is equal to n by 160 is 160n. Carry this across, and then you're carrying this across. You want animals. 180 animals. You want all the n's by itself. So 180n minus 160n is equals to 360. So that's 20n is equals to 360. So n would be 360 divided by 20, which is 18. So how much sides this, what is the interior, each interior angle? Now calculate the number of sides of the polygon, that's 18. Right, and that is how you would have done this question. This one, again, it's a transformation type question. So on the diagram above, draw the image of A after it undergoes a reflection on the line x is equals to -1 and label this image A. And then translation with vector 4 minus 7 and label it as image 2. So image A is undergoing these transformation, 1 a reflection and 2 a translation. So first off, we say that it undergoes a reflection of x is equals to -1. That is this line here. We know that from your object to your mirror line is the same as from your object to your image. So if this is 2 units, this will also be 2, 1, 2, so it'll be here. This is 1, 2, 3. This will also be 1, 2, 3. Right? We know this is 2 units back, so right? So this would be image A. Right, let's connect the points. Right, that is image E. Then they want the second image. So they're telling you that this A underwent a translation of 4 units on along the x-axis and minus 7 units along the y-axis. So 4 units. Let's go. I'll do it in a different color. 1, 2, 3, 4. And then, hold on. 1, 2, 3, 4. They're going 6 units down, they said. No, 7 units down. Let's use this one. Let's use this one. 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6. 6, 7. So it's going to be here. Then we have 1, 2 that's here. Then 2 units that's here. And then 1 unit that's here. And this is how your second image is going to look. This will be image E. Second image E. Right, that is how you would do this question here. But we can check it back because I'm not 100% sure. 1, 2, 3, 4, and then 7 units down. 1, 2, 3, 4, 5, 6, 7. So we say that this point here, after it undergoes transformation, goes to that point. Right, 4 minus 7. And that is how you would have done May, June 2023, number 3.